We've seen multidimensional and multi-level arrays. Now let's take a look at how we represent some other structures besides just plain integers or pointers in memory. In C we have the concept of a struct. A struct is a definition of a composite data type that has sub-elements that are in turn other data types themselves. In this case we have a small struct here with 3 elements inside of it. One is an integer, one is an array of integers, in this case a 3-element array, and the other is a pointer to an integer. So those are 3 parts to that struct. In memory it's going to be laid out as a contiguous set of bytes for each of those parts. The first 4 bytes will of course be the integer I. The next 12 bytes will be the 3 integers of the array A, contiguously allocated. And then finally the last 4 bytes will be a pointer to an integer in a 32-bit architecture. So total for this struct is a 20-byte chunk of memory, contiguously allocated, and we can refer to the members of this structure by the names we've given them. But the members can be of different types. They don't have to be the same. In this case, these are either integers or pointers to integers, but those are very different data types. Okay. So how do we access a structure member? Given an instance of a struct, we can use the dot operator just like in Java. So for example, if we declare one of these rect structs that we've just defined, declared here, we can give it the name R1. Then we can refer to that first integer in R1 by writing R1.I. And that refers to just that first integer that is part of that larger struct that has a couple of other things in it. Okay, if we have a pointer to a struct rather than the struct itself, in other words, we've declared not the struct R1 as we did in this case, but a pointer R to a struct of type rec. In other words, that would be something like the address of the R1 struct we declared previously. We're going to be using the star and dot operators because we first need to dereference the struct pointer, get to the starting location of that struct in memory, and then offsetting that by the position of the member within the struct. Okay, so this happens so often in C that we actually give it a shorthand. We give it the shorthand R right arrow I, and the arrow is drawn as a dash followed by a greater than sign. And that's just a shorthand for doing that dereference first, that's what the parentheses indicate, and then the dot. Okay, so you'll often see this kind of construct in C because we have pointers to structs rather than the struct themselves. So here you see a simple function that is used to set the value of that first element of this type of struct. So it takes a pointer to that struct as an argument and a value to put in that first member, and it says, well, I have that pointer, let's dereference it and offset to I, that first member of the struct, and then give it the value of val. The way that ends up looking in assembly code is very straightforward actually, because we have the value val in EAX, and we're going to have the pointer to the element in EDX, and we're just going to say move that value val to EDX at that address. So the parentheses again are the dereference operator. In this case we don't have an offset because that was the I is the very first element of the struct. So it's at that starting address. If we had to provide an offset, there would have been an additional offset here in front of the parentheses. Okay, so let's take a look at a slightly more complex case, generating a pointer to one of those elements of that array inside of the struct. So in this case, what we would like to do is find the particular element that we're interested in by providing an index. So we're going to provide a pointer to the struct and then an index into the array. And in this case, what we want to return is a pointer to that integer element. Okay, so to return the pointer, what we will do is first do that r arrow a. That gets us to the starting address of the array within memory, within that struct, and then index that array by the appropriate offset. And then the ampersand says, well, I don't want the value there, I want the address of that value, and return that. Okay. How we see that in assembly code is just two simple instructions. The very first instruction computes the offset into the struct. So in this case, the offset is 4 times the index to get to the right position within the array. You'll then notice we'll take that value, which we store in EAX here, and add another 4 offset to it, because that array starts at 4 bytes into the struct. Then, of course, EAX has the offset within the array, and the EDX is the starting address of the struct, that first parameter. We add all of those together, so we start from R, add on the 4 to get to the A portion of the struct, the array portion of the struct, and then we add on the 4 times the index to get to the right element inside the array. And since we're returning just the address, we can stop there after we've computed the address. We don't need to actually do a memory reference.